Hi, my name is François Normandin, and this is a MQTT broker and client architecture example using TLS configuration. This presentation is a continuation of on the MQTT demo that I've done with a server and publisher and subscriber clients over TCP connection. So by then, if you're not familiar yet with the MQTT palette and the client server and connections, please watch the other video that is more generic. There's plenty of information there. But if you are already knowledgeable about this and you want to see how we are going to secure our server and authenticate, the client will authenticate the server before establishing TLS 1.2 communication, then this is the right place. So I will assume that that you have a server that implements already a TCP connection or WebSocket connection, and you have at least two clients here. One is a publisher. One is a publisher that uses the same TCP configuration, and the second one, let me put my code there, is a subscriber which receives publish message and decodes them and uses the same TCP. Now we're gonna, in this video, we're gonna go through the process of creating our self-signed certificates to be able to authenticate our server. If you do have certificates that are not self-signed, by all means just use them, but in here I'm going to assume that you're probably working for now on a very local environment, like you have your Serial, or you even maybe run a inter-process communication on the local machine, so you don't really want to deep dive into having a certificate authority that is external to yourself. But if your company has a root certificate that is valid, then you can probably use that and ask them to sign and assign you certificates for running. But at this point, if you're able to do it with a signed certificate, self-signed certificate, you won't have any problem doing it with your own certification authority. So I hope this is useful for you. So basically, this project assumes that we are in LabVIEW 2020 because LabVIEW as national NI now has introduced TLS 1.2 support into the palette. So let's see what it looks like. You're going to need to go to the data communication. Data communication protocols, and in the TCP, and you have the TLS transport layer security palette right there. And so those are the nodes that you will want to use if you want to create your own TLS authentication for your server client architecture. Now we're gonna make use of an abstraction, which is we're gonna add to our MQTT connection a secured TLS, secured TCP connection. And for that, let's start by going back to our Mqtt open source LabVIEW project and install the Mqtt secured TCP connection that is available on the VIPM community network. Accept the license. This is 0BSD, so very permissive license. You're good to go for commercial use. Now this library at this moment in time only authenticates the server, so it means that if you want the server to authenticate the client, that the client is part of your trusted network, then you're going to need to either upgrade this code. Maybe in the future it's going to be supported bidirectional authentication through the same palette, or maybe you want to just look at the copy this class and spawn your own TCP secured TCP connection class from this source. All right, it's been installed. It's very quick. Now we're going to need to simply go back to our LabVIEW Open Source Project and into Mqtt. You're going to see that now there's a secured TCP connection palette that has appeared. Very simple. There's an example. Let's open that for now. And this is an example that is built on top. It reuses the same example host name as what you'll find in the example for TLS. So if you go into the help find example and you write TLS, you're going to find a bare bone open TCP and TLS implementation directly on the palettes, and it's provided with a few certificates so that you can use. There's also in there kind of very basic instructions on where to go if you want to install and create your own certificates. You're going to see we're going to install a certificate authority package that is on the VIPM community network, and we're going to do that in a heartbeat. All right, so you see it's exactly the same pattern as before, except that we have a configuration node for the server and a configuration node for the client. They're slightly different. The server needs to have its private key, obviously, and the certificate, the trusted certificate. Trusted certificate is what you give to your client so that they can install that on their own machines, and essentially by providing the host name and the trusted certificate, they can authenticate the server. So because the server has its private key essentially to do that. So never share your private key with anyone. Just install it on your server, and that's the basis of a good security. Okay. Of course, we want to use that with the server and the client, so we don't really need this. You can deep dive if you want to see how it's done under the hood, but basic handshaking that happens, and we're going to replace our TCP connection with simply a secured TCP connection. So this is a server. Let's go with the server. The server's TCP connection. If I replace this, I'm going to keep this in case I want it later. But so right now I don't have a password or any keys for that matter, and I don't have a certificate, so that's going to be a problem. I want to configure that on the 8883, which is the Mqtt reserved secured TCP connection port. So it's there you go, remote, everything else is standard. Now I don't have a private key. I don't have a certificate. That's a problem. I need to self-sign at least my own certificate so that I can get going using TCP, using TLS 1.2. Sorry. So what I'm going to do now is just go and update also my clients. And my clients are going to be both the same exact piece of code, and what they need is, well, they need a host name. So that host name is unknown for now, so it's not localhost. Don't use localhost. You'll see that it is really bad. Well, if you go online, you'll see why. It allows man-in-the-middle type of attacks on your network, so you don't want to use that. Obviously, for local communication, it might not be a problem, but and the second thing that you need is the actual certificate that has been shared by your server, so that you can communicate with it securely. Okay. Now, what do? We want to create those certificates. You can go online, you can follow, some processes. There's open source stuff that you can use. What I'm going to do now is to use a tool that I've made, the certification authority Payload, which is also a project that is on the open source project. So you can go there, and certification authority. There's not much. There's a bit of there's a bit of documentation on the project and what is the process that is being used to configure them. So let's go and install. Okay, this is installed. And let's go back into our project. Now you're going to see that in the tools menu, now there's a LabVIEW Open Source Project Certification Authority. And it's a VI that is JKI state machine, and it's going to help you just generate your certificates. At first, you need to have a root certificate. So if it's something that you know about, please load it, but you also need to have the private key to that root certificate if you want to generate certificates that are signed by the root. So if this is not something that you do normally, then at your company and you're not responsible for that, you'll need to learn a little bit more about that. But this exercise here is about self-signed certificates. So I assume that I don't have any root certificates and root private keys because I'm just starting from scratch. So I'm going to open the certificates folder, and this is in LabVIEW 2020, unfortunately, just going on the web, which is annoying because in older versions it would open it would just open the Explorer window like this. And so under LabVIEW data, LabVIEW Open Source Project, there's certificates and CF SSL, which is Cloudflare SSL, which is currently empty. And so just to show that I'm starting from scratch, right now I don't even have an application found. There's a little bit of a bug here. This thing should not have been marked. We're going to need to go to Cloudflare's release pages to find out the latest revision and download the executable for to play with. So go into the assets, and right now it's the CF/SSL for Windows that I need. I don't know. I haven't tested on Linux or any other distros. So all these instructions are for Windows right now. You're going to need to drop this into the CF/SSL folder, and then rename to just cf/ssl.exe. Once this is done, the application here is going to use the command line to talk to the to use this application and generate the self-signed certificates. So first thing is we need a common name and some hosts. So I'm going to do my LabVIEW Open Source Project, and maybe do I don't know, you put your own whatever you want. Then right there, I'm going to delete this element. This is really just for demonstration. Now once you've got your common name and host, you can generate your certificates, and you see that the certificates now have appeared here as root. So the root certificate, this is your trusted certificate. This is a signing request. So those of you that want to have this root certificate signed by a certification authority, you're going to need to supply this this file, and this is your own private key that you should keep very secured. This root key is used only to generate server certificates. So the next thing is let's go to generate some server certificates. Now, this works for batch processing. I only have one server, but if you were to have, let's say, embedded targets all over the place, and you want to generate one specific host name for each, let's say my common name is server 1, or whatever, compact Rio. And my host would be my compact Rio 1.LabViewOS.io, and I can do that blah 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 everywhere. So this is going to be the host name that is going to be very important. Now generate the server certificates, and you see now I've got my Serial certificates. Notice that there are only two. I didn't produce the CSR. There's only the certificate, the trusted certificate, and the key. Well, I don't need the signing request because, well, I'm the certification authority, so I've already signed that. And let's now inspect the certificates. So this is really just for you to, that would know a little bit more about that. If you want to go inside here, you see it's a private key, and it's a base 64 encoded private key. So you see the exact key. This is essentially what you need to supply to the TLS nodes that have been introduced with LabVIEW 2020. And so my Rio will have its own key. So never distribute the root key. The root key is only for signing the certificates for your server. Now the server will be using what we call a trusted chain of certificates, and the trusted chain is that it will build up on the root, essentially. So the root certificate, if you look at it, I'm just gonna, it's not decoded in any way, but if you look at a few of those bytes here, that will change. CCATMJ. If we go into the trusted chain of certificate for the Serial, my server, you'll see that I've got two of them. Well, the first one is the server, and the second one is the root. And you'll see that the root has indeed, it's the copy of the certificate of the root. So it builds up on that trust certificate, that chain of trust. And well, yeah, that's about it. Now, what you need to do is to share your certificate, your trusted certificate, with your clients, and keep this private key on your server. All right. Now, the way to do that would be to copy those files, but because I'm using it from my local machine at this moment, what I'm going to do is I'm going to go much easier on me. I'm going to find my certification authority, and then there's a LabVIEW certificates folder, so that points to this folder here, and I'm going to use this name and build a path. So that's a much easier way of doing it. And I can do the same thing, but instead I'm going to use the key, because that's my private. Whoops, I don't want to do this. Oh yeah, my client only needs a certificate. So there it is. I can delete this guy. I'm going to go on my server. My server needs both the private key and the certificate. And I want my last client to load the certificate. Right, well, if this worked, if I did everything right, that should work on a TLS connection. Well, I bet it won't work. And the reason why it won't is because I didn't provide a host. So you remember when I said, okay, I've got that host value. Well, we're not specifying it anywhere. But here we have localhost. Well, this is a problem. This is not localhost. We're really, using that. What was it? Was it serial 1.lvos.io? So I want to provide the right host name. If I don't provide the correct host name, let's say I go with serial like this, and I connect, it doesn't like it, right? But if I provide the right host name, connect, there you go. I'm going to increase the speed a little bit, and we're going to do the same thing for the second. Like localhost won't work, so serial1.LabVIEW Open Source.io. Connect, subscribe, there you go. Connect, subscribe, unsubscribe, disconnect, stop. This concludes the demonstration. As you can see, it's fairly trivial once you use the client and server architecture provided by the Mqtt broker project. It's very trivial to just swap and go from a secured to unsecured, and to even modify your serializer or reconnect, disconnect. So very I hope it's convenient for you guys. This project, if you find any problems with it, go on the github.com and just add the file an issue, add your comments, screenshots, tell me what doesn't work, what works, and thank you very much for listening.